Hello, chemistry students. It's time for your Chemistry of Aerospace Science lesson number 11 in Unit 1, the Big Bang Theory, or at least Chemistry of the Big Bang. So today is all about radiation and radioactivity, kind of an introduction to the concept of radiation. So our goals for this series of slides is to differentiate between radioactivity and radiation, know the three most common types of radiation that occur from nuclear processes, and then analyze at least three sources of radiation and determine materials that are specific to shield each type of radiation. So first things first, what is the difference between radiation and radioactivity? Well, if we were to break these down into two columns, radioactivity versus radiation, radiation is the energy transfer. And you've seen that before in your physics class when you talk about the three different ways to transfer energy: through conduction, through convection, and through radiation. And we just got done seeing convection in the tectonic plates. So that's the energy transfer. Radioactivity is an emission of that radiation due to some spontaneous change in the composition of nucleus. And that's an important piece here. Actually, two important pieces. One, it's a spontaneous change. It happens naturally. And second, it changes the composition of the nucleus of an atom. So we're getting a change in the makeup of the atom. So one of the biggest sources of radiation is the ground. Here we are finishing up Chemistry, Earth, Space Science, the mostly Earth and space part of it. And we talk about the rocks, talk about the soil and what layers and such. Well, one thing is that there is uranium in the soil and in the rocks, and it turns out decaying from uranium, then changing into radium, and then changing into radon. And radon is a not so healthy for you radioactive gas. So this little graph shows here different places that we can get our different sources of radiation. Radon is a big one. It comes from rocks, so some in the human body, there's cosmic rays, and there's a bunch of things that are man-made, like medical sources and nuclear power. These are all different. So notice that as uranium becomes radium, try again one more time. Uranium becomes radium, which becomes radon. You're having the atom actually change identity. So what determines the element's identity? The number of protons, the number of neutrons, or the number of electrons? Did you say protons? That would be correct, because this means the number of protons inside the nucleus is going to be changing during these nuclear radiation reactions. Well, the one big one that's mentioned here is radon, and radon is a not so good element. So why is radon dangerous? Well, one thing is you very likely have been exposed to radon, and it is not very good. Radon is invisible, odorless, and it's radioactive gas, and we already saw from the previous slide, it's formed from uranium decay in soils and rocks. The radon then seeps into buildings through cracks and can accumulate in poorly ventilated areas like your basement. If you have a very old house, one that's probably more than 50, 60 years old, your foundation probably isn't as secure as it can be, and you probably have radon seeping into your basement through the walls. Now, most houses of that age have a radon system to remove the radon from the basement or from any closed-in spaces. It's unpredictable. Radon levels can vary widely based on where you are, how much uranium is in the soil and such. But you can't see it, you can't smell it, so you don't know that it's there unless you test for it. And importance of awareness, well, since it is undetectable, we need to make sure we are very aware of where it is, where it might be, and then also try to get it tested regularly. So one of the things is, because radon is a colorless, odorless gas, it is inhaled into the lungs, and it breaks down into the radioactive decay particles of alpha particles specifically. Those decay products attach to dust and get trapped in the lung lining and make sure that the harmful ionizing radiation can get into your body. That ionizing radiation damages your lung cells and your DNA, increasing the possibilities for long-term lung cancer. And the more you're exposed to radon, the more serious your risk is of having very serious and very long-term damage. Some other facts about radon and lung cancer is radon is the second leading cause of lung cancer and is the number one cause of lung cancer for non-smokers. Radon-related lung cancer symptoms often appear very, very late once the damage has been already done. So you don't really know you've been exposed, and you don't really know you have any symptoms. And the only way to take care of this is to test your home or have some type of a emission system to remove the air from your basements, replace it. So why is it important? Well, testing is the only way to detect radon. I said that a couple times. And since it's odorless and invisible, we can't really say, wow, my basement smells like radon. You can't tell. Second is its reduction system. You can set it up so that it pulls the gas out of your house, bringing in fresh air and reducing the concentration of the radon in those closed areas. And again, the more you know about it, the earlier you find out about it, the more you can get the radon under control in your enclosed spaces, the healthier you're going to be. Okay, so that's my little rant on how unhealthy radon is and how we can manage to make sure that we are being properly exposed and minimizing that exposure. So, I'm going to take a step back. What is an ion? So from the earlier lessons of lessons 9 and 10, we talked about an ion at one time. An ion is just a charged atom or a charged set of atoms. It's charged because it's either lost electrons or gains electrons. A cation, the positively charged ion, is one where they loses electrons. And the negatively charged ions, they're called anions. They are a result of having the atom gain electrons. So why am I mentioning ionization right here? Because ionization is, the chemical term ionization is the removing of an electron to create a cation. So let me say that again. The chemistry definition of ionization is when it removes electrons from the atom, making it positively charged and making it charged positive, making it a cation. So you can see here the radiation comes in. This is going to be an example of ionizing radiation, and it's going to kick out that electron from the shell and leave you with a cation. So what does the word ionize mean? Is it to remove a proton from the atom, to keep an eye on the prize, to excite an electron up to one energy level, or to remove an electron from the atom? If you said D, you're correct. Now, when we were talking about the different types of radiation or electromagnetic radiation, we kind of divided it into things that are stronger, higher energy than visible light spectrum, and those that are lower energy than the visible light spectrum. Well, the ones that are from the visible light spectrum and below, those are all non-ionizing. They're safe. They don't cause any damage to tissues and cells and DNA. But the ones on the top end, the ultraviolet, the X-rays, and the gamma rays, those are all ionizing. The reason why they are so dangerous is they will remove electrons from the atoms in your body, changing the structure, changing the makeup, and causing possible mutations. So there's a couple different types of ionizing radiation. One of them is alpha particles. So alpha particle looks a lot like a helium nucleus. Notice it has helium, but it has a +2 charge. So if I think about it, helium is the second element on the periodic table. That's why you have the 2 here. And this 4 up here, that's the mass number. Now remember, the mass number is the number of protons plus the number of neutrons, or the number of nucleons. So how many protons, neutrons, and electrons does a helium nucleus have? Does it have 2 protons, 4 neutrons, and 4 electrons? 2 protons, 4 neutrons, and 0 electrons? 2 protons, 2 neutrons, and 4 electrons, or 2 protons, 2 neutrons, and 0 electrons? If you said D, you would be correct. So one of the types of radiation that can be emitted is the alpha particle. The second type is a beta particle. Beta particle is special. We're going to talk more about the beta particle and the alpha particle in our next lesson. But the beta particle looks like an electron, but it is not an electron that's been removed from an atom. It is actually an electron that's a result of a proton being broken down into a neutron. Sorry, bring that back. It is a result of a neutron being broken down to form a proton and an electron. And we'll talk a lot more about that tomorrow, but beta particle looks a lot like electron. And then last type of the big three is gamma radiation. Gamma rays are just high energy, and they're on the top end of that electromagnetic spectrum. They are just very, 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 very high energy. There is no really physical aspect to it except for the photon of that energy, and it is very, very high energy and does a lot of damage. So if we think about how alpha, beta, and gamma particles can be shielded against, outside the body, the beta particles and gamma particles are a lot more dangerous, with alpha radiation being just simply blocked by your skin or by your clothing. However, if you happen to ingest alpha particles, that's going to cause a lot of damage because it is the most aggressive when it comes to ionizing. So think about it. If you're breathing in that radon, and that radon emits alpha particles, you're having this ionizing energy inside your body causing all kinds of damage. Something is normally laid out there is that alpha particles are pretty weak. Alpha particles, you can be blocked by a piece of paper. Beta particles will just go whizzing right by paper, but a pretty thick piece of plastic will stop them. Gamma rays and X-rays, they need to be blocked by something really thick and intense like lead. And a neutron, which happens to be on this visual, but we won't really talk too much about the neutron. The neutron as a radiation piece, ionizing radiation, it can just go straight through lead, can be blocked by a very, very thick piece of concrete. Next thing to recognize is the fact that you probably consume some radioactive material every day, because there are a few common pieces of food, bananas being one of them, that have a radioactive component. That's potassium-40. It's a radioactive isotope. It breaks down into potassium-40. It breaks down to calcium-40 and emits beta particles. Other places you can find potassium-40 is with Brazil nuts and with lima beans. For the record, Mr. Farron hates lima beans, probably the most unappealing food to me. But bananas, Mr. Farron eats way, 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 way too many bananas. So give or take the radioactive product of potassium-40 from my bananas, or the fact that I avoid lima beans like the plague. So I am going to link this video into your Schoology classroom so you can watch it if you wish. It kind of breaks down to 3 types and gives you a little bit more of an overview. And here we are at a nuclear power plant, and they're talking a little bit about how they contain the different radioactive sources. So that's on your own. I can't show that here because, well, it would be a YouTube violation. So in summary, radioactive processes are spontaneous. One of the most common ones that we see on a daily basis is having uranium decay and getting that radiation, that those alpha particles. Radiation is essentially a energy transfer by either waves or particles, but they also can be emitted as part of the particles of radiation. Many types of electromagnetic radiation, but only the high energy are the ones that are dangerous. That's the ones that are above the visible light spectrum, the UV, the X-rays, and the gamma rays. When we say something is ionized, that means it has been removed of one or more electrons. Three most common types of radiation are alpha particles, beta particles, and gamma rays. And alpha particles can be shielded by a piece of paper, beta particles by plastic, and gamma rays can be held back by lead. And finally, not all exposure to radiation is bad. For instance, you've probably eaten radioactive foods such as bananas, unless you eat an enormous amount of them. And sometimes I think that I worry myself with how many bananas I've eaten. Sometimes it's not going to be any significant problems. So that's it for this particular lesson. Come back for lesson number 12. That's going to be on radioactivity. Until then, toodles.